Welcome to this comprehensive deep dive into AWS identity and access management, specifically focusing on IAM roles and policies. This presentation will take you through everything you need to know to become proficient with IAM. We'll start with the fundamental concepts and gradually build up to advanced scenarios. By the end of this session, you'll understand how to design secure, scalable access patterns for any AWS environment. IAM is the foundation of AWS security, and mastering it is crucial for any AWS professional. Let's begin this journey together. The IAM Foundation. Before we dive into roles and policies, let's establish the core IAM concepts. Think of IAM as the bouncer at an exclusive club. It decides who gets in, what they can do once inside, and how long they can stay. The four pillars of IAM are users, groups, roles, and policies. Users represent people or applications. Groups are collections of users with similar access needs. Roles are assumed identities with specific permissions. Policies define what actions are allowed or denied. Understanding this hierarchy is crucial because it determines how you architect your entire AWS security model. Every AWS API call goes through IAM for authorization. Understanding IAM policies. IAM policies are JSON documents that define permissions. Think of them as contracts that specify exactly what actions are allowed, on which resources, and under what conditions. Every policy has 5 key components: version, statement, effect, action, and resource. The version tells AWS which policy language version to use. Statement contains the permission logic. Effect is either allow or deny. Action specifies what can be done. Resource defines what the action applies to. There's also an optional condition element that adds context-based restrictions, like time of day, IP address, or MFA requirements. This is where policies become really powerful. Regarding policy types and management, AWS offers several types of policies, each serving different purposes. AWS managed policies are pre-built by AWS and cover common use cases, such as S.3, read-only access, or EC2 full access. These are maintained by AWS and automatically updated. Customer-managed policies are created by you and can be customized to your exact requirements. These give you complete control but require more maintenance. Inline policies are directly attached to a single user, group, or role. The choice between these types depends on your governance requirements, reusability needs, and maintenance preferences. Most organizations use a combination of all 3 types. Introduction to IAM roles. IAM roles are one of the most powerful and misunderstood features of AWS. Unlike users, roles don't have permanent credentials. Instead, they provide temporary credentials through a process called assuming the role. Think of a role as a hat that different entities can wear. When you assume a role, you temporarily gain its permissions and lose your original permissions. This is perfect for cross-account access, service-to-service communication, and federated access. Roles solve the fundamental problem of distributing credentials. Instead of embedding access keys in applications, you assign roles that provide temporary, rotated credentials automatically. Role trust relationships. Every IAM role has a trust policy that defines who or what can assume the role. This is separate from the permissions policy and acts as the first line of defense. The trust policy is crucial because it determines the attack surface of your role. You can restrict role assumption to specific AWS accounts, specific users, services like EC2 or Lambda, or even external identity providers through SAML or OIDC. A common mistake is creating overly permissive trust policies. Always follow the principle of least privilege. Only allow the minimum entities required to assume the role. Service roles in detail. Service roles are IAM roles that AWS services can assume to perform actions on your behalf. For example, when you create an EC2 instance, you can assign it an IAM role. The EC2 service then assumes this role and provides temporary credentials to applications running on the instance. This eliminates the need to store access keys on EC2 instances, which is a major security improvement. The credentials are automatically rotated and delivered through the Instance Metadata Service. Each AWS service has specific requirements for service roles. Lambda functions, ECS tasks, and RDS instances all use service roles but with different trust policy requirements. Cross-account access patterns. One of the most powerful use cases for IAM roles is cross-account access. This allows users or services in one AWS account to access resources in another account without sharing credentials. The pattern involves creating a role in the target account and configuring its trust policy to allow assumption from the source account. Users in the source account can then assume the role to gain temporary access. This is essential for multi-account architectures, vendor access, and organizational isolation. It's much more secure than sharing access keys between accounts. Federated access with OIDC. OpenID Connect Federation allows external identity providers, like GitHub Actions, CircleCI, or corporate identity systems, to assume IAM roles without long-term credentials. This works by configuring an OIDC identity provider in IAM and creating roles with trust policies that validate JWT tokens from the provider. The external system presents a token, AWS validates it, and if valid, provides temporary AWS credentials. This is incredibly powerful for CI/CD pipelines and eliminates the need to store AWS credentials in external systems. It's also more secure because the tokens are short-lived and cryptographically verified. SAML Federation Deep Dive. SAML Federation enables enterprise identity providers like Active Directory Federation services to grant AWS access to corporate users. This creates a seamless single sign-on experience. The process involves configuring SAML identity providers in IAM, setting up federation in your corporate identity system, and creating roles that can be assumed by federated users based on SAML attributes. This allows employees to access AWS using their corporate credentials without separate AWS user accounts. It's essential for large enterprises with existing identity infrastructure. Permission boundaries. Permission boundaries are an advanced IAM feature that sets the maximum permissions an entity can have, regardless of the policies attached to it. Think of it as a guardrail that prevents privilege escalation. This is particularly useful in environments where you delegate permission management to developers or other teams. You can allow them to create and attach policies while ensuring they can't grant more permissions than the boundary allows. Permission boundaries work with both users and roles. The effective permissions are the intersection of the identity-based policies and the permission boundary. Understanding how AWS evaluates policies is crucial for designing secure access patterns. AWS uses a specific order of evaluation that determines the final access decision. The evaluation follows a specific order: implicit deny first, then explicit deny policies, explicit allow policies, resource-based policies, and finally organization SCPs if applicable. This means that a single explicit deny anywhere in the evaluation chain will result in access being denied, regardless of any allow statements. This is why understanding policy precedents is so important. Session policies and temporary credentials. When you assume an IAM role, you can optionally specify a session policy that further restricts the permissions for that specific session. This provides additional security by limiting what the temporary credentials can do. Session policies are particularly useful for cross-account access where you want to grant limited permissions for specific tasks. They can only restrict permissions, never expand them beyond what the role normally allows. The AWS STS service manages these temporary credentials and handles the policy evaluation. Understanding STS is key to mastering advanced IAM scenarios. Resource-based policies. While we focused on identity-based policies, resource-based policies are equally important. These are policies attached directly to AWS resources like S.3 buckets, KMS keys, or Lambda functions. Resource-based policies specify who can access the resource and what actions they can perform. They're evaluated alongside identity-based policies to determine final access. The key advantage is that resource-based policies can grant access to principals in other AWS accounts without requiring role assumption. This is how S.3 bucket policies enable cross-account access. Policy conditions and context. Policy conditions make IAM incredibly flexible by allowing context-based access control. You can restrict access based on time of day, IP address, MFA status, request headers, and many other factors. Common condition keys include AWS requested region for region restrictions, AWS multi-factor auth for MFA requirements, and AWS principal tag for attribute-based access control. Conditions are where policies become truly powerful, allowing you to implement complex security requirements without creating dozens of separate policies. Best practices for policy design. Designing effective IAM policies requires following established best practices. Start with the principle of least privilege, granting only the minimum permissions required for the task. Use AWS managed policies where possible, but don't hesitate to create custom policies when your requirements are specific. Always test policies in a safe environment before applying them to production. Regularly audit your policies using tools like IAM Access Analyzer and AWS CloudTrail. Remove unused permissions and consider implementing permission boundaries for delegated administration scenarios. Effective role management is crucial for maintaining security at scale. Use descriptive names that clearly indicate the role's purpose and scope. Implement a consistent naming convention across your organization. Regularly rotate role credentials by updating trust policies and permission policies. Use external ID values for cross-account roles to prevent the confused deputy problem. Monitor role usage with CloudTrail and set up alerts for unusual assumption patterns. Consider implementing time-limited roles for high-privilege operations. Troubleshooting access issues. When users can't access resources, systematic troubleshooting is essential. Start by checking the identity-based policies attached to the user, group, or role. Then verify any resource-based policies on the target resource. Use AWS CloudTrail to examine the actual API calls and their results. The IAM Policy Simulator is invaluable for testing policy combinations before deployment. Common issues include typos in resource ARNs, incorrect condition evaluations, and conflicts between explicit deny and allow statements. Security monitoring and compliance. IAM security is not a one-time setup but an ongoing process. Implement continuous monitoring using AWS config rules, CloudTrail logs, and Access Analyzer findings. Set up alerts for privileged role assumptions, policy changes, and access from unusual locations. Regular access reviews should be part of your security routine. Use AWS Organizations SCPs to implement organization-wide guardrails that prevent certain actions regardless of IAM permissions. This provides an additional layer of security. Advanced patterns and future considerations. As your AWS environment grows, consider advanced patterns like attribute-based access control using tags, automated role provisioning with infrastructure as code, and integration with external governance tools. Stay current with new IAM features like IAM Anywhere for hybrid environments and enhanced condition keys for fine-grained control. Remember that IAM is constantly evolving. What we've covered today provides a solid foundation, but continue learning and adapting to new security requirements and AWS capabilities. In conclusion, and looking at next steps, we've covered a lot of ground in this comprehensive exploration of AWS IAM roles and policies. From basic concepts to advanced federation patterns, you now have the knowledge to design and implement secure access controls. The key takeaways are: always follow least privilege, use roles instead of users for programmatic access, implement proper monitoring and auditing, and regularly review and update your access policies. To continue your IAM journey, practice these concepts in your own AWS environment, staying updated with AWS security best practices, and considering AWS certifications to validate your knowledge.